So this is section 1.3 in honors calculus, and I think it would also be section 1.3 in AP, although there'll probably be two videos for AP. All right. So now that we have the idea of what limits are about, you know, that you're looking to see when two sides of a graph come together, whether there's a point or not, there might be a hole, but where the two sides of a graph come together, that's where we say we have a limit. Okay, so what if I'm not just looking at graphs? What if I don't have the graph? What if all I have is the equation? How can I tell what the limit is? All right, well, there's a couple of things that you're going to try. The first thing that you're going to do is you're just going to try to substitute. Substitute. So it's kind of like, if I can substitute, that means there's an actual point there. So it's like I'm plugging in an x in order to find my y. So for example 1, if I want the limit as x approaches 1, I'm going to substitute in a 1 everywhere I see an x and see what I get. Okay, if I put in a 1, I'm going to have 1 squared plus 2 times 1 all over 1 plus 1, which is going to give me 3/2. So that means there's an actual ordered pair at 1 comma 3/2. Okay, so the limit is 3/2. Okay, let's try number 2. If I substitute in a 0, I'm going to have 0 squared plus 2 times 0 all over 0. Then that equals 0 over 0. All right, that's undefined. But undefined doesn't mean the limit doesn't exist necessarily. Undefined means I don't have enough information to know what the answer is. Okay, so notice I plugged in a 0 everywhere I saw an x. All I really needed to look at was, is there going to be a 0 in the denominator, right? On number 1, if I had plugged in a 1 to the denominator, I got a 2, which means it's okay, I'm going to get an answer. But on number 2, when I plugged in a 0 in for x in the denominator, that's the bad thing, right? When the denominator turns out to be 0. Okay, so if you can't substitute, meaning if you can't just plug it in, if you end up with a 0 in the denominator, you have to try something else. Okay, well, if you can't substitute, the next thing you might try is, can you factor? And the whole point of factoring is, once you factor it and get everything to cancel out, can you then substitute? So you're always going to come back to trying to substitute. Okay, so on number 2, if I factor the top, I've got a common factor of x. So that's going to leave me with x plus 2. And in the denominator, I just have an x. Well, do you see that those x's out in front are going to cancel? So what I really have here, it's still a limit. I haven't evaluated this limit yet. So it's still, the limit is x approaches 0, but now it's just of x plus 2. Okay, so now can I substitute? Well, sure. If I plug a 0 in for x, I'm just going to get 0 plus 2 is 2. And basically what that means is, remember back in, I don't know, algebra 2, pre-calculus, when we talked about how when factors cancel, that's where you have holes. So here's a situation where you have a hole, but the two sides of the graph are still coming together, and the predicted y value there would be 2. Okay, so when I look at number 3, can I substitute? We'll just start with the denominator. If I put 0 into the denominator, I'm going to have the big bad thing, right? I don't want 0 in the denominator. And I don't know how I'm going to factor that. I mean, I've never factored anything like that before. Okay, so if you can't substitute, maybe you can't factor. Something else you could try is to rationalize. Now, you may or may not remember, and by the way, once you rationalize, that's always leading us to trying to substitute. Rationalize, we did that back in geometry. Remember when we were trying to get rid of a square root in the denominator? But you can rationalize a numerator also. Like, I could get rid of those square roots in the numerator, and you might be saying, why? Well, because it's going to work in such a way that I'm going to be able to cancel some things, and eventually I'll be able to substitute. Okay, so in order to rationalize this, I'm rationalizing the square roots that are in the numerator. Basically, I have to multiply the entire numerator by the conjugate, meaning I have to multiply it by the square root of x plus 5 plus the square root of 5. Notice the conjugate means you change this minus to a plus. That's the conjugate. But whatever you do to the top, you have to do to the bottom. So I'm going to multiply the denominator by the exact same thing, by the square root of x plus 5 plus square root of 5. Okay, so here's what I have. the limit as x approaches 0. Now, when I multiply, I know this looks ugly, but it's just a binomial times a binomial. I'm just using FOIL, okay? So when I multiply the first square root of x plus 5 times the square root of x plus 5, that just gives me x plus 5. And I'm in the numerator here, okay? And then when I do that, the outer, notice I'm multiplying the exact same parentheses, except one's a plus and one's the minus. It's kind of like multiplying x plus 2 times x minus 2. Isn't that the kind where the outer and the inner are going to cancel and it's just going to be the first minus the last? Well, the same thing is going to happen here. In fact, that's why we're multiplying by the conjugate, because we know that the outer and inner will cancel. So now I need the minus the last, so square root of 5 times square root of 5 is just 5. And then in the denominator, we do not want to distribute. We want to keep it in factored form. And I'll show you why in just a minute, okay? And that's always going to be true on these. So keep the x on the outside, and then keep the parenthesis, square root of x plus 5 plus square root of 5. I know it's looking ugly, okay? Now, is anything going to simplify? Well, yeah, don't those 5s cancel? And now that those 5s are gone, won't these x's cancel? So what I actually have, let's see what's left here. What I actually have is still a limit, because I have not evaluated yet, meaning I haven't substituted yet, as x approaches 0. And if nothing's left on top, it's like there's a 1. And in the denominator, all I have is the square root of x plus 5 plus the square root of 5. Okay, I know it's ugly, but can you substitute? Remember, we're putting a 0 in for x, okay? If I put a 0 in for x, I'm going to have 1 over, well, 0 plus 5 is 5, the square root of 5 plus the square root of 5, which would be 1 over 2 square root of 5. So that's my predicted y value. Again, I know it's ugly. I don't care. That's my predicted y value. Okay, and let's look at number 4. So on this one, can we just substitute it? Remember, in order to see if you can substitute, start with the denominator. Well, no, because I'd have a 0 in the denominator. Okay, it's not something you would factor. It has no square roots. It's not something you would rationalize. So what are my other options, you ask? Well, I'm glad you asked. So number 4, you might simplify. Oh, I don't know why I changed to green. I want to keep it consistent up here. You might simplify. And when I say simplify, a lot of times what that means is that you have a complex fraction. What's a complex fraction? Well, that's when you have like a fraction within a fraction. So we're going to simplify this so that it's no longer fractions within fractions. Now, I would have showed you how to do this back in pre-calc and also in algebra 2. You may have forgotten. But the best way to simplify a complex fraction is to multiply the numerator and denominator by the common denominator. Okay, so you notice on the top, I have a denominator of x plus 2, and I have a denominator of 2. So I'm going to multiply that entire thing by 2 times x plus 2, because that would be the common denominator. But whatever you do on top, you have to do on the bottom. Okay, so let's start with the top. Well, I'm going to have to distribute, I'm going to have to distribute this 2 times x plus 2 to the first fraction, and then minus, and then I will distribute it to the second fraction. And what's going to happen, so I've got the limit, as x approaches 0. Okay, so when I multiply that 2 times x plus 2 times 1 over x plus 2, do you see that the x plus 2's are going to cancel? And so all I have left is the 1 times 2, which is 1. Okay, and when I distribute it to this 1/2 right here, do you see that the 2's are going to cancel? And so all I have is 1 times that parenthesis x plus 2. So I got to bring down that minus sign. And then I have x plus 2. Because of that minus in front, I need to make sure and put that x plus 2 in the parentheses. And then this is all over. Again, don't actually multiply out the denominator. Keep it in factored form. So I have the x that was out in front, and then I have the 2, and then I have the x plus 2. Now, a common mistake I see with a lot of students right now, they'll say, oh, hey, look, I can cancel out these x plus 2's, but I know you guys wouldn't do that, right? Why can you not do that? Well, because on the top, that x plus 2 is a part of subtraction, right? You can only cancel parentheses when they are factors. So what you need to do is think of that numerator, distribute the negative, right? So I have 1 minus x minus 2. Wouldn't that actually be negative 1 minus x? Am I thinking correctly? Hold that thought here. Oh, I'm sorry, I see a mistake. You probably caught it, but I did not catch it at the beginning. When I was multiplying that when I multiplied that 2 times x minus 2 by that 1 over x plus, remember how the x plus 2 is canceled, and I said, so all you have is 1 times 2, but what is 1 times 2? It's not 1, right? It's 2. I probably even said 2, but sorry about that. Okay, so now when I simplify on the top, and I distribute that negative, yeah, I have that negative x, but do you see that you're going to have a 2 and then minus a 2? So on the top, all I have is negative x. On the bottom, I have the x, and I have the 2, and I have the x plus 2. And so now, do you see that I can cancel those x's because they're both factors. Neither one of them are part of addition or subtraction. So here's what I have left. The limit as x approaches 0. On top, I just have negative 1. On the bottom, I have 2 times x plus 2. Now, can you substitute? In other words, can you put a 0 in for x? And if you do that, you're going to have negative 1 over 2 times 2. So negative 1/4. So again, what that means is originally there was a hole. I know that because when I originally tried to substitute it in 0, it was undefined. But the two sides of the graph are going to come together, and the predicted y value would be negative 1/4. Okay, so we've got 4 different things that we've tried. First of all, try to substitute. If that doesn't work, maybe you can factor and then substitute. If you have square roots, maybe you can rationalize and then substitute. If you have a complex fraction, maybe you can simplify and then substitute. Okay, but look at number 5. So I start by trying to put in a 1, right? So I'm going to have 1 over 0. Can't do it. But this is not something I can factor. There's no square roots. I can't rationalize. It's not a complex fraction. There's nothing I can do to this 1 over x minus 1. So the last case scenario is if none of those things work, then you look at the graph. And you might be saying, well, why don't you just look at the graph first? Because in section 1.2, we looked at the graph every time and it seems so easy. Well, that's true. But this is no calculator. So you don't know what the graph is. I mean, unless it's something it's a parent function that you know and you can look at the graph, great. Okay, look at number 5. Isn't that a parent function that we know? Isn't that just the 1 over x graph? So if you want to think about 1 over x graph, it's moved 1 unit to the right? That's where your vertical asymptote is, something like that. So what's the limit as x approaches 1? Well, remember we said if there's a vertical asymptote, it does not exist. On number 6, if I substitute, again, start with the denominator. Oh, I'm going to have 0, right? Okay, so is this one we're going to graph? I don't think so. What should I do? Yeah, hopefully you see that x squared minus 1 and everything in you wants to factor, right? So you've got x minus 1 over x plus 1 times x minus 1. So let's see. What's that going to be? What I actually have here is the limit as x approaches 1. Apparently I'm getting lazy on my writing limit. And what I have left here is 1 over x plus 1. Well, again, isn't that just the 1 over x graph? But this time it's moved 1 unit to the left. So let's think. 1 over x, 1 unit to the left. And I want the limit as x approaches 1. Well, hey, can I substitute? Sure you can. Won't you just get 1/2? So in this case, I graphed it, but I didn't need to because after I factored, I could have just substituted, right? Probably shouldn't have. Go to the graph last. Don't put down a graph if you don't need it. Okay, so let's get to some that have all kinds of words. What? All right, let's look. So I'm given 4. I wonder if that's supposed to be an M. Oh, yeah. Okay, so I've got a limit for M as we approach 0 and a limit for P as we approach 0. And then I have a limit for m as we approach 5 and a limit for p as we approach 5. Okay, I see. So use the limits for m and p to evaluate the limits below. So this one says, evaluate the limit as x approaches 0. This means 7 times m of x. Okay, well, if the limit of m of x as x approaches 0 is 10, then this is just going to be 7 times 10. If I didn't tell you how to do this, you would have assumed this to be the case. Okay, letter B. Notice this is the limit as x approaches 5, so we're talking about these over here. So what it approaches matters. So in this case, as x approaches 5 of m, I'm going to get 8. And as x approaches 5 of p, I'm going to get 4, which equals 2. Okay. Letter C. In this case, we want x approaches 3. I don't know what it is. I mean, I've got x approaches 0, and I've got x approaches 5. How am I supposed to do x approaches 3? And the answer is, well, if I were substituting, I would say it's going to be whatever m of 3 plus p of 3 is, right? Because you put your 3 in place of x. But since I don't know what those are, I can't really do anything else. Like if I had an equation for m, great, I could do it. Or if I had a graph for m, great, I could do it. But in this case, I can't really do anything else. Okay. Number 8. Now notice we're not using the m and p's anymore. This is a whole different problem. Okay. So when I first look at this, I'm thinking, can I substitute? And now notice it's not x approaches 0, it's h approaches 0. So I'm substituting 0 for h. Well, do you see in that case, I'm going to have a 0 in the denominator? That's the bad thing. Okay. Is this something that you might factor? Well, you actually could, but probably most people aren't going to think of that. But yet you're like, well, it's not a rationalizing. And I mean, I guess I could simplify, even though it's not a complex fraction, I could do some things to change this, right? Like, what if I square out that x plus h? You know, what if I just take this part? Like, I'm going to leave the 3 there. If I were to square that out, don't you square the first? Remember the shortcut I showed you? And then you double the product. So it's going to be 2 times. The product would be x times h. And then you square the last. So h squared. And then you still have your minus 3x squared. And you still have all over h. But do you see what's going to simplify? Yes, I'm going to distribute this 3 to everything. But can we do 2 steps at once here? Do you see that this 3x squared is going to cancel with this minus 3x squared? Okay, so here's what we have. The limit as h approaches 0. So I'm going to finish distributing the 3. I have 3 times 2x is going to be 6xh. And then 3 times h squared all over h. I still can't substitute, though. I'm still going to have 0 in the denominator. All right, well, am I done? Well, what can I do now? Hey, what do you see on top? Can't you factor out an h? Okay, so let's do a common factor of h. It's going to leave me as 6x plus 3h all over h. What do you notice? Those h's on the outside are going to cancel. So what I have here is the limit as h approaches 0. Notice it continues to be a limit because I haven't been able to substitute yet. You don't get rid of that limit notation until you actually do your substitution. Okay, so what do I have left? I have 6x plus 3h. Okay, so now can I substitute? Notice I'm substituting 0 in for h. If I plug it in for h, I'm going to have 6x plus 0. And you might be thinking, well, how can you have an x in your answer? And I understand that because so far we've only been doing limits from the standpoint of looking at a graph. But this is kind of going to be our branching off where we're going to really start to jump into the calculus here pretty soon. So it is okay to have x's in your answer. All right, so that is section 1.3 on evaluating limits.